Good morning to all. So in this class, we are going to discuss about the topic discrete Fourier transform in digital signal processing. So the prerequisite of this topic is Fourier series and Fourier transform. So introduction. So any periodic function can be expressed in Fourier series representation. The discrete time Fourier transform, so we call it DFT, which is represented by x of omega of a discrete time sequence of x of n, is a periodic continuous function of omega with a period of 2 pi. So it cannot be processed by digital system. So if you want to process a signal in digital form, we cannot do directly. So from the continuous signal, we are going to transform into the Fourier series, Fourier transform method. So then only we go with the discrete system. Then we go to the discrete time Fourier transform method. So for processing by digital system, it should be converted into digital form. The DFT, discrete Fourier transform, convert to the continuous function of omega to discrete function of omega. So this is main factor. Then DFT allows us to perform frequency analysis on a digital computer. So the objective of the Fourier transform or any transform is we are going to change the input signal from time response into frequency response. So the DFT of a discrete time signal of x of n is a finite duration discrete frequency sequence. This is denoted by x of k. So where x of n is the input signal of finite duration, then equivalent discrete frequency sequence we represented by x of k. So the DFT is obtained by sampling one period of the Fourier transform of x of omega of the signal x of n. So here we are going to take the sampling. So from the name itself, you know that discrete time signal. So discrete time signal means we cannot be able to represent all the input signal into the present signal. Okay, so we are going to sampling whether it is a based on the ns value. So we can able to take 50 sample for one time, or 500 or 5,000 or 50,000, whatever it is depends upon the system operator. Okay, the Fourier transform x of omega of the signal x of n at a finite number of frequency point. So the sampling is conventionally performed at n equally spaced point in the period of 0 to 2 pi. So this is very important. N equally spaced. So we are going to take the sampling period as n equally spaced. Okay, each and every samples are going to take so this period only. So here the sampling period is 0 to 2 pi. So the omega is nothing but sampling frequency. So this can be represented by 2 pi kn divided by k divided by n, where k is nothing but 0 to n minus 1 time period. So why the discrete Fourier transform is important? So first, it allows to determine the frequency content of a signal. So in each and every signal, we can able to determine the frequency parameter. So that is to perform spectral analysis. Okay, so spectral analysis is equivalent to the frequency response analysis. The second application of the DFT is to perform filtering operation in the frequency domain. So this is very another important thing. So which content in the signal is required, which is not required, we have to separate. Then we can able to eliminate that particular signal which are not at relevant to the original signal. We can able to eliminate, that is we called noise. So that type of functioning is in your DFT function. So let x of n be the discrete time sequence with the Fourier transform of x of omega. Then this x of n of DFT can be represented by x of k equal to x of omega, where omega is nothing but 2 pi k divided by n, where k is nothing but 0 to n minus 1. So in a DFT and IDFT, discrete Fourier transform, then inverse discrete Fourier transform. This is two type of things we have. So one is n-point DFT of a finite duration sequence of a length L. So where n is always greater than or equal to L is defined by the generalized function x of n is equal to x of k, where summation of n equal to 0 to n minus 1 x of n e power minus j 2 pi n k by n. Otherwise, the exponential term we can replace by weight factor wn power nk, where k is nothing but 0 to n minus 1. Then similarly, if suppose in a given situation the given function is x of k, so we need to find the x of n. So we go to the inverse discrete Fourier transform function. So x of k is given of the length of n. So now we are going to find x of n. So this IDFT of x of k is nothing but x of n is equal to 1 divided by n, summation of k equal to 0 to n minus 1 x of k exponential of j 2 pi n k by n. So this e power j 2 pi n k n we can replaced by wn power minus nk. So this wn represented by Twiddle factor. So for n-point DFT, pair of x of n, x of k is denoted by x of n to x of k. This is DFT. The x of k to x of n is nothing but IDFT. So this exponential form of discrete Fourier. So as mentioned in the previous case, the real periodic discrete time signal x of n of a period of n can be expressed as a weighted sum of complex exponential sequence. So this weighted sum of complex exponential sequence is represented here, that is e power minus j 2 pi nk by n, else e power j plus 2 pi nk by n, whether it be a DFT or IDFT. Okay. As the sinusoidal sequence are unique only for digital frequencies from 0 to 2 pi, the expansion has only a finite number of complex exponential. The exponential form of Fourier series for a periodic discrete time signal is given by, so this two term will be given. So whether x of n is given, so we go with 1 by n summation of k equal to 0 to n minus 1 x of k e power j 2 pi n k by n. Otherwise, x of k is given, we go with n equal to 0 to n minus 1 x of n e power minus j 2 pi n k by n. So for all the values of k and all the values of n. So if you are trying to change the exponential term into the wn, so we go with n equal to 0 to n minus 1 x of n wn power n k. So this is the equivalent form of x of k. Okay. So now we go with a very simple problem. Here the two sequences are given. First one is x of n is given for 4-point DFT, and the second one is x of k is given. So we have to find IDFT. So using direct method. Okay. So so 4-point, this 4-point means we are having 4 inputs: 1, minus 1, 2, and minus 2. Okay. So given sequence is x of n is nothing but 1, comma, minus 1, comma, 2, comma, minus 2, right? So where capital N is nothing but 4-point, and the length of the sequence also L is equal to 4. Okay. So no padding of 0 is required. So we know that DFT of x of n is given by x of k is equal to n equal to 0 to n minus 1 x of n w n power nk. Okay, w n power nk is nothing but e power minus j 2 pi by n into nk. So substitute directly. So capital N is nothing but 4. So 4 minus 1 3. So n is varies from 0 to 3. X of n e power minus j pi 2 pi by n. Here we substitute n is equal to 4. So this is n equal to 4. So 2 by 4 can be cancelled. So j pi by 2 into nk. This is the expression. Now we are going to substitute the function. So now x equal to 0. So for x of k, so we have length 4. So we are going to calculate 4 values of k here. K equal to 0 and k equal to 1 and k equal to 2 and k equal to 3. Okay. X of 0 is nothing but n equal to 0 to 3, x of n, then substitute here k equal to 0. Substitute k equal to 0, e to the power 0, 1. So x of n e power 0 will be remaining. Now you substitute the summation value into the inner term of the function. So x of 0 plus x of 1, x of 2 plus x of 3. So now we have to take this x of 0, 1, 2, 3 value from the given function. So there will be no arrow mark is pointed here. So we assume that the first value will be a x of 0, second one is x of 1, and third one is x of 2, then fourth one is x of 3. So x of 0 plus x of 1 plus x of 2 plus x of 3, which is equivalent to 1 minus 1 plus 2 and minus 2. So this will be equivalent to 0. So for given x of n value, the given x of k is nothing but 0. So similarly, we go with x of k equal to 1. So where k is equal to 1, the same function n equal to 0 to 3, x of n e power j pi by 2 into n into k. So this k will be 1 here now. Okay. So x of 0, expand this function, x of 0 plus x of 1 e power minus j pi by 2 plus x of 2 e power minus j pi plus x of 3 minus e power j 3 pi by 2. Okay, x of 0 is given is 1, directly substitute 1 plus x of 1 is minus 1, here minus 1, and also we have to substitute e power minus j pi by 2. E power minus j pi by 2 is nothing but cos pi by 2 minus j sin pi by 2. Then cos pi by 2 is equal to 0 and j sin pi by 2 j sin pi by 2 is equal to minus 1. Here is a sin terminology. So cos pi minus j sin pi. So we have substituted minus j here. Similarly, the function 2 and function 3 will be represented here. Here e power minus j pi. E power minus j pi means minus 1 plus j0. So minus 1 will be represented here. The third one 3 pi by 2, which is a sinusoidal term coming into the picture because 270 degree of the quadrant form. So we have to substitute 0 plus j. So now add all the values, you will get it minus 1 plus minus j. Okay. So this is your second function. Now we go with the third function, x of 2. Similarly, n equal to 0, n equal to 0 to 3, x of n e power minus j pi n, and then expand all the expression, you will get it 6. Now x of 3, you get it minus 1 plus j, then expand all the 4 value, x of k is nothing but 0, minus 1, minus j, 6, minus 1 plus j. This is your equivalent discrete Fourier transform for the given x of n signal. Okay. So now the second problem is in the given values x of k. Now we have to find the value of x of n. So we go to the inverse method. So the equivalent formula is nothing but x of n is equal to 1 by n summation of k equal to 0 to n minus 1 x of k wn power minus nk. Okay. So now 1 by n summation of k equal to 0 to n minus 1 x of k wn power minus nk is nothing but e power j of 2 pi by n into nk. So now substitute n is equal to 4, 4 minus 1, 3. So 1 by 4 summation of k equal to 0 to 3 x of k e power j pi by 2 of nk. So substitute here k equal to 0, k equal to 1, k equal to 2 and k equal to 3 for all the given expression for 4 times. Then you will get it for each answer. X of 0, the final answer should be equal to 2.5. X of 1 minus j 0.5. X of 2 minus 0.5 and x of 3 is 1 plus j0 point. Just you are going to substitute all the given value into the corresponding equation, you will get it the answer. So now you have to consider only things. So what is the value of e power j pi, e power j2 pi, and e power j3 pi, and also pi by 2, 3 by 2, 5 by 2. So these answers are very important to substitute for the given value. Okay. See here e power j pi means minus 1 plus j0. It is given here. Then next one is e power 2 pi. So e power 2 pi means so e power 2 pi means here 0. Then e power 3 pi minus 1. So likewise it goes on. So thank you for your listening. So we'll meet in the next class. Thank you.